Let's make an explorable world map like this that reveals the map image below as you explore the world. We can zoom in, we can zoom out, we can even add some offsets to pan around our image, and all of this is taken care of mostly by a single material that will display our world map. Let's get into it. Starting in an entirely empty project, the finished version, as always, will be below for patrons and YouTube members to go check out. But the first things that we want to do is import our images. So I've got a player icon and a map image. The map image, it is quite important that it is an image with transparency, and the border pixels need to be entirely non-opaque, because we're going to be panning this thing around. And if any color pixels touch the edges, it's going to be extending those into infinity, and we don't want that. So make sure that whatever image you have just has a little bit of padding with empty space on the edges. The way that we're going to be dealing with this is through a render target, but not a normal render target. Let's go into texture here. You might be used to using normal render targets, but we're going to be using a canvas render target. This is a specific type of render target, which will call something like RT map mask, and this type of render target will actually let us draw to it through code, which is really quite neat. Opening up the render target that we just made, you might notice that it's only 256 by 256 pixels. That largely will be enough. You might be thinking, but the map that I have is like an 8K texture. It's still likely going to be enough, because we are not going to draw in any super sharp, intricate detail on this. All that this is going to hold is a rough mask that is going to just be circular shapes and blurriness. So it being a low resolution is actually fine. You don't want this to be too high of a resolution, because as this thing becomes higher resolution, everything that we're going to be doing with it becomes exponentially more expensive. So let's go into the third-person character blueprints and get started with what we want to be doing here. I'm going to add in a begin play event, and we're going to be setting a timer by event. I'm doing this on a timer because what we're really doing here is something for making a world map. I'm going to be previewing it as if it is a mini map, and you can use it as a mini map, but really the intention here is it being a world map that you access through like a menu. So you don't need this to update in real time, you don't need this to update every tick, and we're going to be doing a couple of things that are fairly expensive that you might not want to be doing too often. So let's set this to be a looping timer of about 0.1 seconds, and then hook up a custom event to it, update map mask. In order to do that, we need to first make a variable for our map mask, and that's going to be of type canvas render target 2D. Compile the blueprint so that we can give this a default value, which is going to be the render target we just made. If we then drag that in, we can begin a draw canvas to render target operation. And that'll give us the output for the canvas that we're actually going to be drawing to, but it'll also give us a context handle, important in a moment, and the size of the texture that we're working with. This means that if we code these things properly, we can actually set everything up here to be independent of the size. So if we later decide that we actually do want it to be like a 512 by 512 render texture because we just need a little bit more detail out of it, everything should work fine because we have this and we're going to be using this. We'll get back to that when it becomes relevant though. For now, the canvas, we can draw a material to it. There's a couple of different things that we can do. Material is the most flexible because we're going to make a material that's effectively going to work as the brush that we're going to be painting with. We then need to give in a screen position and a screen size for the brush. Everything else we can more or less ignore. We'll make the material in a moment. First, we drag off the context and we type end to make sure that we end the draw canvas to render target as well. Now, making the brush material is actually fairly easy, all things considered. Let's make a material, call it brush, and open it up. This material is going to be of domain user interface. That's effectively just saying, hey, this is going to be a 2D material. And the blend mode we're going to set to being additive, because a brush, every time we stamp it onto something, is going to need to add to what's already there. And the easiest way to just make a simple circular brush is to just use the radiant gradient exponential and put that into the opacity here, and then set the final color output to being pure white with the alpha being 1. and that'll get us a just circular brush that we can use. Now, this is a little intense for what I want to do with it. So what I'm going to do is I'm actually going to set the density to a lower value. You can just hold down 1 and click, by the way, for one of these little scalar nodes. The default value for the density, if you hover over it, you can see is 2.33. I'm going to set it to 0.6. And that's going to make a much softer, much more gradual gradient that's going to be good for what we want to do with it. Of course, since this is a material that we're using as a brush, you can do whatever you want with it. You can add in detail around the edges with a noise texture. You can just make this a noise texture. You can make this any other given texture that you want to put into it. You can go really crazy with what you want to do here. After you've made whatever you want to make though, you just drag this in as the render material. And then what it's going to do is it's going to, if we just set this background as a checkerboard real quick, we can see this is the size of the quote-unquote image that this material is going to be. And whenever we render this, it's going to render this as an image onto our render target at a certain position at a certain size. So our render target by default is 256 by 256. So if we set the screen size to like make vector real quick, 50 by 50, not 501, that's a little too large. It's going to be taking that soft little gradient we had at a size of 50 pixels by 50 pixels. So we can actually set the preview size to like be that, right? And it's going to be putting it in here at any given location that we give it in. So how do we get that screen position? That's the most important thing, right? How do we convert where we are in the world to where we want to draw on this render targets? And for that, there's a couple of things that you need to know. Number one, which world coordinates is going to correspond to the origin point of our texture. Origin points for textures are usually, effectively always, the top left corner. This is pixel number 00. Which coordinate in our world is going to correspond to that? Ideally, if you still have to build your world, what you would do is you would build out your entire game world, starting at 00 and then only building into the positive directions. Nothing is then going to have a negative coordinate in your entire game. That makes the math a little bit easier. However, you might not have that, and this template actually doesn't have that. In this template, world 00 is the center of this little arena here. So what we need to do is we need to find the outermost corner in the negative direction and figure out what the coordinate for that is. So in this case, that will be -2000, -2000. So in our calculations, everything that we have to do with world space, we just add 2000, 2000 to it. That way, it's going to effectively treat this as being 00 in all of our coordinate calculations. Now, if you then keep on building your game and you build out into this direction and suddenly the outermost corner is at 5000, 5000, you would need to update that value in your code to reflect your new outer corner. We also need to know the outermost corner in the other direction. What coordinate are we working with here? I just happen to know that this is entirely symmetrical. So this is positive 2000, positive 2000. So if we add the 2000, 2000 to that, this would be 4000, 4000. So in this render target, this will represent 00, this will represent 4000, this will represent 4000, 4000. Then all we need to do is figure out in a percentage where our player is between those 2 points, and we can map that to a pixel in this render target. That sounds like a whole lot of stuff to do. Trust me, it's actually pretty straightforward. Let's get into it. In our character blueprint, what we do is we first and foremost get the actor location. Then we offset that by the value that we were discussing before. In this case, it will be 2000, 2000 to zero out our outermost corner to be our origin. So that will be just adding 2000 to both of those coordinates. Then we divide this by the size of our entire world. Again, in our case, that will be 4000 by 4000. So we divide this 4000 by 4000. It's a little bit of a quirk that you need to be aware of here. You can't divide this with being a value of 0. You need the z to be a value of 1. Even though we're ignoring the z value here, if you do a division operation on a vector and any of the components are 0, it's just going to output a vector that's entirely 0, so we don't want that. If we just do this and we print out this vector, you will actually see that we will print out 0.5, 0.5, on every run through of this timer. Then if I run toward this corner over here, it counts up towards a value of 1, 1. As such, you can also imagine that this then counts down to 0 and counts down to 0 as well. That's going to be a very valuable thing to have for a couple of different reasons later on as well. But for now, all we need to do is we need to multiply that with the size of our render target here. And you can see it has been just rendering a thing at the top left corner. We'll look back into that in a moment. But if we just multiply our percentage by the size, we're going to get a pixel at that percentage X and that percentage Y of our render target, and that's going to be the pixel that we want to draw at. So straight up, we can just put that into the screen position, and you will be able to see this update in real time, actually, as we walk through the world. So let me just put that there, and you'll be able to see it starts drawing at the center, roughly at the center. You might notice that it's a little bit offset, and you'd be right, but yeah, you can see that this updates just as I walk around like this. A couple of little issues. Number one is it doesn't clear out. If I start playing now again, it just keeps adding on to what I already did. So we need to clear it on every begin play, which is easy enough. We can just on begin play, get our map mask and clear render target 2D. We can even give it in a color that it needs to clear to. In our case, that'll just be clearing it entirely to black, and that'll just clear it out on begin play. Now, this thing still not exactly centered, because what is happening is the coordinate that we're giving in is actually correct, but it's drawing our little brush with the coordinate being the top left corner and then drawing out from there, which you can see if we just look at where the top left corner of this circle is, that actually is the center. So that makes sense. We just then need to offset this so that it draws the center of our brush at the center. Now this is easy enough. All we need to do is get our screen position and subtract from that half the size of our brush size. So just divide this by 2. You can right click this pin and convert it to a float, just to make it a little easier, then put that in for our screen position. That will fix the offset issue, and now everything will just be exactly at the center. Now, just to make sure that this is entirely scalable with different resolutions, as I mentioned before, what we're going to do is we're going to be dividing our vector that we make here by 256, 256, and then we will multiply that back with our actual texture size. And that's going to be the thing that we put into all these other things, like the screen size and this division node. Right now, all this is going to do is it's going to take my size, divide it by 256, and then multiply it by 256 again. It's still going to be the exact same thing. It's the exact same size, there's no difference. Difference being is if I now make this 512 by 512, and I zoom out a little bit, you will see that proportional to the rest of the texture, it is the same size. Because now what happens is we divide it by 256 and multiply it by 512. We just normalize it so that we can multiply it as well. If we didn't do this and we just put this in like that without the division and multiplication, you'll be able to see that the resulting point at a higher resolution is lower or smaller. That's the straightforward and easy part. There's a little issue that we have left. I'm going to set this back to 256 real quick, because again, that will be large enough for 99% of cases. If we just stand around, you can see that the dot that we represent becomes brighter. And then when we walk through, it's a little like wispy. And then when we stand still for a bit, it accumulates and it becomes bigger and bigger and bigger. We don't want that because that's ugly. What we want to do is before we decide to draw this material, we're going to be checking the pixel that we want to center our brush on and check if it is already white. Because if it's already white, that means that we've already drawn on this location and we don't need to reapply it, because that just creates that accumulation and that's not what we want. Easy to do though. We get our map mask and we read a pixel raw from there. That just lets us put in a pixel coordinate, an X and a Y, and gives us a linear color output. Now, it does warn you that this is an incredibly inefficient and slow operation. Again, you don't want to really be doing this too much all over the place. Hence why we are limiting this to running on a timer and not just throwing it into a tick event. Now, how do we get the X and the Y position that we want to sample? Well, that's actually pretty easy because we already have our normalized position, multiplied by our size. So all we need to do is we need to break this vector and just hook in x to x and y to y. And that's everything there is to it. It'll add in some truncation nodes for us. And we're sampling the pixel that we want to look at. Then we break that pixel and we get the red, green, blue, and alpha channels. Since we're just applying this as pure white, you can look at any of the color channels. And we're going to check, hey, is this less than, let's say, 40% bright? You might need a little tweaking. Maybe you want to go down to like as low as 20% brightness or as high as like 80% brightness. But 40% brightness from my testing is a pretty good indicator to look for. If it is already more than 40% bright, that means that we're like in the middle of one of these circles, or at least near the middle of one of these circles, so we don't want to be applying anything. But if it is less than 40% bright, that means that we're on the edge of one of these strokes and we want to start applying some more. If we just check this for being 0, there's going to be too much space in between every single application of our brush. 40% seems to be a pretty continuous way to deal with this. But this also depends on the timing of your timer, the scale of your world, the distance, the speed that you can travel through the world, all that kind of stuff. Anyway, so if that's true, we draw material. If that's false, we just skip draw material and we go immediately into end draw canvas. With that, you'll be able to see, if I just keep this a little bit more zoomed in, it is not going to accumulate in the same way anymore. I can just walk around a little bit and it won't accumulate when I stand still. So that is fixed. That is pretty much the character code all done. Now we need to make a material to actually display this stuff with. So let's make that material. We'll call that a world map. And this is going to take in a handful of different things. Number one is it's going to be taking in our map texture and then also our render targets. You can just draw those in and they'll function as textures in your material. Later on, we're also going to be putting in our little player indicator icon. That's going to be a thing we do in a moment. First thing first is we can fairly easily just lerp this input texture between 0 and the texture itself based on this texture's, the render target's output as the alpha. If we then put the material domain here into user interface again, because it's a 2D UI element, put that into the final color, you can immediately see everything is black aside from where the render target displays white. So that's the world revealing part of all this. If we just make a user interface thing for this, user widgets, WBP map, I'll make this a canvas panel with an image in it. The image I'm going to set to, I don't know, 450 by 450. That's a pretty good size for previewing this. Again, I'm going to be displaying this as a mini-map for previewing purposes. Mostly this is more so intended to work as a proper world map within a menu that you don't constantly look at, because it's going to be updating not super smoothly. You could do it as a mini-map. It would just be a little bit more expensive. Either way, we're going to set that brush to render as our world map material. So we can just world map, drag that into there, and make sure that our world map is actually compiled. Otherwise, it's going to scream at us. And just like that, we have our world map that we still need to add to the viewport. So let's create widgets. That'll be our world map. Add to the viewport. Hook it up in the execution flow. Just little things that you sometimes forget, right? So now when I walk around, you can see it's revealing the map. Again, it's a little stuttery because it's only doing it 10 times a second. If you hook this up into tick, it'll of course be a lot smoother, but it's also going to take a lot more performance instead. So not necessarily something that you do want to do, but yeah, that's going to make it insanely smoother, as you can see like this. I'm going to stick with it being on a timer now. So now let's add the zooming, it following the player, having an indicator for the player, and allowing you to offset away from the player as well. All three of those are going to be parameters that we keep track of in a material parameter collection, which you can just make like this. I call this MPC for material parameter collection, and we'll call this map params or something like that. This is going to need 3 parameters in total. Number 1 will be our zoom scale. So that'll be a default of 1, and we'll call that zoom scale. And then we'll have 2 vector parameters. And the first one will be our player UV, player location, player normalized location, whatever you want to call it. This is going to hold the location of the player in that 0 to 1 scale. And then we'll have a map pan offsets. In the player character, we want to set these values before we actually start implementing this into the material. And on mask updated here, all that we really need to do is we need to set a vector parameter value and hook this up. Then we can give in the collection that that parameter will belong to. So that's that collection right there. And then we set the player UV to, hey, wouldn't you know it, we already have that normalized version that we made before. This is a version of the player's location in the world, normalized to a 0 to 1 scale. So we can just kind of give that in and be done with it. It's just as easy as that. Now, if you don't have it automatically convert this, by the way, because maybe if you hook this up in a different order, this output pin might turn blue. You can just break this vector and you get the X, Y, Z. If it's blue, you'd only get an X and a Y. And you can make this color, because it takes in a color technically as its vector input. And you just hook in the X to the R and the Y to the G, and that way you can convert it manually yourself. Then we can add in a mouse wheel down and mouse wheel up. Obviously, within a proper game, you would make these like actual input actions. We're just going to do it with the old legacy stuff. And this is going to be zooming in and out for us. So that does something fairly similar. But first we need to get a parameter value, and that's going to be a scalar parameter in this case from the same collection. It's going to be our zoom scale. And the reason that we're getting these is because we're going to get the current value for them and then add to them a certain value. So let's say 0.25. And then we want to clamp this float between, let's say, 0.2 and 1. This is going to be the fraction of the UV. So 0.1 means that it's zoomed in 5 times, and 1 means that it's zoomed out all the way. And then we're going to set the scalar parameter value, which, of course, going to be the same parameter in the same collection, just with this new value. And then mouse wheel up, we just copy all that over, and instead of adding 0.25, what we do is we subtract. This might be the wrong way around. I always get mixed up with what feels natural. This is one of those things where you just flip a coin, see if it feels good. If it doesn't feel good, you move these two things around. Because now that we have everything set up as far as parameters go, we can start doing some fun stuff. I'm going to just kind of make some room here, and we're going to start with adding in a texture coordinate node. Now, what we want to do when we scale in and out of this thing, I'm just going to quickly only display final color on this one. Scaling this by just multiplying it is going to scale it from the top left corner. So we don't really want to do that. Like if you do this and multiply it by 0.2, it's going to zoom in on the top left corner. We don't want that. We want it to zoom in on the center. So first what we need to do is we subtract 0.5. And that's not how that works. We subtract and then add into the node 0.5. And that then goes into our multiply node. And then we add back in that 0.5 afterward. So what that does is it moves our entire texture, as you can see right here, so that the middle pixel is all the way up here in the top left corner. Then it scales from this top left corner, and then we add back in that 0.5 that we took away, so that this middle pixel goes back to the center. And that way, it scales to the center. Now, you have seen that there's like some tiling issues going on, where if we zoom this out, for instance, like, let's say we zoom it out twice, it actually properly scaling from the center now, that's good, but it's duplicating, and we don't really want it to duplicate. So we can go to this texture sample node and say, either use your sampler source from the texture assets, we can change it there. We can also just change it in here and say, hey, I want you to clamp. This way, it's always going to clamp at the edges of the texture. There might be a little bit of this glitchiness going on. If you just set your MIP level to absolute 0, it should get rid of that. I believe it's a little bit more expensive this way, but for that single texture, it's not that big of a deal. So now we want to put in our actual zoom level parameter. We can just drag in the parameter collection and select any of the parameters in it. So zoom scale, hook that up into here, and there we go. Now, as we increase and decrease the zoom scale, we can actually, like, in real time see that we can zoom in and out. Fantastic. Instead of directly putting this into here though, it's usually just kind of nice to keep things organized to make a named reroute node and call that inputs UV. This way we can change everything about the UVs and stuff like that, and we don't have noodly messes all over the place going everywhere. And then we can just use that pretty much as a variable like you would do in Blueprint as well. And you can put those in there and there. Make this the final output color again. And now we can once again see, if we open this up, it now zooms in both of them at the same time. So it's just kind of nicer than having noodles all over the place. Now we want to add in our player indicator, which in my case tells you to subscribe, over top of all this. So what we do there is we add in just one more lerp, and all that we're going to lerp between is the output from this and then just the image from this. And we're going to be using the alpha from our indicator as well to drive that lerp, and now it's overlaid. Just as easy as that. Of course, we want this to be a little bit smaller. We don't want this to be this big. So what we're going to do is this is going to have a separate texture coordinate input. We're going to do the same thing. We want to subtract 0.5 because we're going to be scaling it from the center. And we want to multiply it by, let's say, 10. That's going to make it 1/10 the size. And then we add back in that 0.5 that we took away before. And it's going to be a little bit smaller in the center of the screen. Once again, we want this to probably clamp and not wrap, and use MIP level absolute 0 full resolution. And now we've got a little indicator at the center of our screen. Since we always effectively want this thing to be at the center of our screen, we want to slide our UVs for these two inputs under it. This thing itself isn't actually going to have to move until we start implementing the offset, which moves everything as a whole. So let's take a look at how we can use the player input value for its location to offset the map under us. And while we do that, we immediately also just might as well add in the map pan offset. So you see me copying over one of these nodes. What we're going to do is we're going to change this one to being player UV, make another one, make that the map offsets, and we're just going to be adding those together. Then we component mask that in the R and the G channel, because these actually give you RGB and A values, and we're going to be using this for the UVs. So if you try to do any math between those two types, it kind of freaks out. So we need to just say, hey, we only care about the R and the G, the X and the Y, the U and the V, all the same channels, just with different names. Then we subtract, I think you can see where we're going, 0.5 from this, and then we just add that into another adding node here in the whole list. And that offsets everything. Isn't that perfect? And that is because it now thinks that we're at the top left corner of our level. So I think the default value for our player UV probably should be R0.5, G0.5. And now when we go back over, you can see it is back there where it should be. Again, we can see this updates in real time. This is as if we're walking through our level. The 0.5 thing is just for preview purposes. And again, we can also then try to preview our offsets. That also works just fine. Let's see how that works. Make sure to apply that, and then we should be able to see that it starts panning around with us. We can zoom in and we can zoom out. Now you probably want the player indicator to also become bigger and smaller as you go in and out with your zoom. That seems altogether like a thing that makes sense to do, doesn't it? So what we do is we go back into our little section here for the player indicator. There, instead of multiplying it by 10 directly, what we do is we multiply it by 10 times our zoom scale. So we already have our zoom scale here. We can just kind of copy that over and put that in here. This way it will stay the consistent size. If we zoom in, it actually becomes bigger as well. And like that, it's a little bit better. Effectively, we have everything we want for a map now. As a little bonus, we're going to be doing the little offsets that we can add to it for panning around it, but that's relatively easy to do as well. Because good news, for this section of it, we already have our pan offsets entirely set up. There's nothing else we need to do for it. However, when we pan around, we also want this, our subscribe button, our player indicator, to not be at the center of the screen anymore, of course. So we're going to need to add in another offset, and we're going to add that offset in before our multiplication. So what we do is we get our map panning offsets. Again, we mask that in the red and the green channel because we only care about the first two components. And then we divide that by our zoom level. After subtraction, but before the multiplication, add in an addition node to add in the value for this. And now I'm not going to bother setting up all kinds of inputs for this because you can figure out how to change the values for these based on everything else that we've discussed today, and it's going to take a while to set up the inputs. I'm just going to show it to you through directly manipulating these values. As you can see, everything works fine. I can zoom in a little bit, and if I then just F8 out of this, I go into this interface and I change this value, you can see that I can pan around no problem and everything stays exactly in the position that it should be. And then I can zoom back out again and everything works with set offsets. And as an aside, while I was editing this video, I realized that this doesn't include you saving the render target at all in any sort of way. And the issue with saving the render target is that it is kind of difficult to do because you could export it as an image and then re-import it, which is one method to do it. Comes with a couple of issues because then you might get like annoying with file paths and all that kind of stuff. Save the raw pixels, which is super expensive to do and takes up quite a lot of just space. So one other way that you could do it is have your save object, just pretend like we have a save object here, and keep track of every time that you stamp your draw material, which screen position you're stamping. Because then we can just reconstruct the exact same stamps whenever we load a game file. After we draw material, we would just like imagine that you have a save object somewhere around here. So let's just say this comment represents load save object. Then you would also just put this thing into an array in your save object. So let's add a reroute node for that. And then what we can do is add to save object array. So that would just be a vector2 array that just keeps track of the coordinates that you have drawn to. Then loading that game back up would be as easy as getting that array, just doing a for each loop over it, and just doing a begin draw to canvas and using the same material, using the same screen size, all that kind of stuff. Just at every single screen position that you previously saved, draw that material again. And that should pretty much just identically reconstruct the state of the map when you last saved your game. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Student tier supporters, Oiku, Earl, Monseville Urno, and my Cave Digger tier supporters, Mauricio Farias.